Okay, so this week we're looking at the methods of research. This quote by Albert Einstein really highlights what science is about, because the fact that we do research shows that we don't really know what we're doing or what's going on. What do you think that means? I want each of you to ponder that as we move forward in this lecture. Now, at its most basic and simplified, the difference between quantitative and qualitative can be expressed as this. Quantitative is only concerned with numbers, and numbers, while qualitative is only concerned with words, words. So how do quantitative and qualitative research methods look at the world around us? What assumptions do they have? Well, with quantitative research, it is based in this idea of positivism. Remember, that's what we talked about a week or two ago. So it's this idea that there is this reality that is singular in nature, it is stable, we can understand everything about the world around us, and we can continue to learn absolute truth. Qualitative, on the other hand, is based on the idea of constructivism. Now, this assumes that reality is subjective, so there are multiple realities, and that these realities are socially constructed through both individual and collective perspectives. So, in other words, this is where we say that there's a difference between truth and fact, right? So, with truth, what you view as an individual, that's your truth. And someone else may view the exact same situation and derive a completely different truth based on that. Whereas fact is supposed to be an irrefutable concept that you can't argue and that there is no different perspective that's going to change the meaning of it, right? Think about gravity. Something goes up, something comes down. It doesn't matter what your personal truth is on that. The fact is that gravity, works in particular ways. Now, we can go into the depths of that, if we really wanted to, but we're not, because that's really not what this lecture is about. But it's just kind of showing how the two methods look at the world a little bit differently. Quantitative, there are singular facts, singular universe. Qualitative, it is subjective. Now, the purpose of quantitative research is to establish relationships, particularly causal relationships, so that we can understand the cause and effect of different phenomena. And in other words, it is the idea that the goal of science is to explain why things happen and predict when those things will happen. Qualitative, on the other hand, is concerned with understanding how reality works from the perspectives of the participants. And this means that for qualitative research, there is more research participation from the scientist than would be found in quantitative. So what this means is where quantitative might be looking at abstract numbers, the qualitative side, the researcher has to be present. They're either watching or interacting with participants. Now, thinking about how they differ in their approach to research and the processes that they use, quantitative uses the traditional scientific method that you're probably all most familiar with. It moves from hypotheses to theory. These are the types of experimental research designs that we would see, or the correlational designs that we would see, and these are used to reduce error and bias and reduce the impact or influence of variables outside of what we're studying. Qualitative, on the other hand, arises out of something we would call grounded theory, and we'll talk about what that is in a few minutes, but the theory comes from the data, and we move towards hypotheses of why that theory might apply. This type of research uses ethnographies, interviews, content analysis, panel studies to understand the individual reactions to a phenomena. Now, when we think about how does the scientist play a part, in quantitative, scientists are mostly detached from the study in order to avoid bias. Now, this leads to the false belief that this improves objectivity and reduces subjectivity, but it really doesn't, because in most cases, the quantitative researcher is still choosing the variables that they are studying and how those variables look. In qualitative research, the researcher is pretty immersed in the situation and the phenomena being studied. And so this will go into a few risks that we'll talk about when we start breaking down the different types of qualitative research. But it leads to the potential for bias because the researcher has a direct hand in the study itself. Some other differences: quantitative results are obtained through the use of measurement and statistics. Now, this usually produces a context-free generalization. So what this means is that we can take findings from this quantitative research and generalize it to a bigger population and say that whatever we find in the sample is reflective of what we'll find in the general population that it was drawn from. This means that people can easily replicate our findings. So we can see how we can find very simple explanations, but as technology changes, those explanations can become a little bit more nuanced and a little bit more complex. It also means that findings are presented as statements of statistical probability, so greater or fewer odds, more or less likely. Qualitative, on the other hand, the results are obtained through a detailed description of a phenomena. This means that what we derive from that research is very contextually bound, and it may only apply to the people in that sample, which is why it's really hard to generalize qualitative findings to a larger population. It's possible, but it's very hard to do. Now, we verify results in qualitative research not through replication, but by extending our understandings of a phenomenon to others through others. This means that we're presenting our findings more as a summary or a narrative, and we place the importance on reducing complex realities to simple explanations. Now, thinking about qualitative again, the aim of qualitative analysis is complete detailed description versus quantitative research. We classify features, count them, construct models, and attempt to explain what observed. On qualitative, we discern the design as the study unfolds, as it goes about, as we are actually doing the study. So we may create new questions, for instance, if we're interviewing. In quantitative, the study is carefully designed before we even begin collecting data. In qualitative, the researcher themselves are the data gathering instrument, whereas in quantitative, researchers will take already constructed tools, so maybe secondhand data sets or questionnaires or other forms of equipment to collect the data. In qualitative, data is often words. Most often it's words, but it can also be pictures or objects, whereas in quantitative, data is presented in the form of numbers or statistics, specifically like descriptive statistics, so what percent of a population has X. Qualitative data tends then to be more rich, and it also tends to be a more time-consuming process with less ability to be generalized to the bigger population. Quantitative data, however, though, tends to be very efficient. It's really easy to collect and very fast to collect, and you can collect data from a large number of people. The problem, though, is that you can't contextualize that data into any specific event or history necessarily because of the nature of the questions asked. So let's take a second to look at some research methods. So first, let's look at the idea of what is primary data versus secondary data. Primary data is data that has been generated by the researcher themselves. So whether they use surveys, interviews, experiments, they are the ones collecting the data and using the data. Secondary data is more of what I do, where I take existing data generated by either large government institutions like the census, healthcare facilities like hospitals, or other organizations like NORC, and we take that data and analyze that. So some examples of research that could use primary data or secondary data is we could do cross-sectional studies. This is where we look at a population at one time point. So maybe we collect data during the pandemic. We are only looking at the people in that sample during the pandemic, and that's what we're generalizing to. Case control studies are where we are looking for disease outcomes by going back in time usually. Cohort studies, usually moving forward in time, where we follow a group of people to see do they develop a disease. And randomized control trials, these are the gold standard of research. This is where we are using a control group versus a variable group to determine whether or not, say, a cure actually works. So in a cross-sectional study, as I said, data is gathered at one point in time. This is often through the use of surveys. Now, it can make inferences about correlation and say how strongly two things are associated with each other. It is really hard to make inferences about causality. Now, you can do it, but it is very difficult. And the reason that it is difficult is that the most important element for determining causality is time order. But if everything is collected at the same point in time, you can't say which event happened first, X or Y. You can just say that X and Y are associated. Now, how do you prove correlation in a cross-sectional study? Well, the most common way would be what we call consistency of the data. And this is where if I pull a sample from multiple populations across multiple time points and I find the exact same finding, I could start making an argument for causality. But this is really hard to prove and people will give you pushback. So we typically don't try to prove causation with cross-sectional studies. So case control studies, as I mentioned, are retrospective. So what this means is that we start with the disease outcome. So let's just say we're looking at mesothelioma, which is a form of lung cancer. We would then go back in time and look at whether or not an individual had been exposed to a particular exposure, so asbestos in this case. And so what we would do is pull people who had had the disease outcome and go back in time to see, did they develop the disease from an exposure. And we calculate then the risk in both the cases and controls, and we often present this in odds ratios, so greater or fewer odds, to understand the risk associated with having the exposure and developing the disease. Now, a cohort study is basically the opposite of a case control study. So in this case, we start with a group of people that share either a similar exposure or a similar life event. So let's take the nuclear meltdown at Fukushima in 2011. What we would do then is pull everybody that was exposed and we would follow them forward for a certain amount of time. It could be 10 years, 20 years, 30 years, 50 years, whatever it is that we're going to follow them. And we look to see, do these individuals develop a specific disease of interest? So do they develop a specific type of blood cancer, for instance? This allows us to determine prevalence, and we can then create measures of relative risk or rate ratios to understand what your risk of developing the disease based on the exposure actually is. Now, as I mentioned, randomized controlled trials are the gold standard for determining associations and the most common used for determining causation. And in this, we randomly assign individuals to exposure. It's also the only reliable way to control from confounding variables, which are spurious associations. So the most common spurious association would be murder and ice cream. So as sales of ice cream increase, murders increase. Does this mean that, after someone commits a homicide, they go to Ben and Jerry's? No, of course not. Those things are not actually linked. The actual variable causing both of those to happen is temperature. So as it gets warmer, people tend to eat ice cream. And also as it gets warmer, we see more homicides because people are out and about. Temperatures are easy to flare and things like that. So we can control for confounding really easy. The problem is, though, is not every type of experiment can be actually randomly assigned. You can't assign someone to losing a limb or not losing a limb in order to test a prosthetic, for instance. So the randomized controlled trial, while the gold standard, is not the only type of controlled trial. They're broken down into different forms. You can have the blind, the double blind, or the triple blind studies. We'll talk more about those a little bit later. But this is typically the top of the hierarchical pyramid. Now, when we think about research using secondary data, these are what people typically use to pull lit reviews, to do meta-analysis, or to analyze existing data collected for another purpose. So thinking about those types of data sets that we might use for cross-sectional studies, we could take data that someone else collected for those purposes and do another cross-sectional study. So this is why I said some of those can be used with primary or secondary data. I should make clear that the randomized control trial is always primary data. Now, starting in the 20th century, we begin to shift away from viewing quant as the only reliable method, and we start seeing this push for qualitative research. Now, I have to make clear that QUAL is still not universally respected. You will still see people claim that qualitative research is not science. This is not true, but you will see people who make that comment. And as we go through this class, we will kind of look at that claim, and we will analyze it and see what the value of qualitative research is in science. So according to the qualitative research perspective, researchers can only come to understand the social world through the participants' interactions within it. This means that we're interpreting, because reality is multifaceted and diverse, and it's really hard to quantify it. So think about something like love. How do you quantify an emotion like love? And if I ask you to define it and then to assign it numbers and a scale, you would all probably give me a different answer, and it would kind of lose its meaning, right? Because now we've actually defined it, this emotion that is not so easily defined, and the minute we define it, we've actually reduced what its meaning actually is. So this ends the first part of the lecture. Please go listen to part 2.